here. Okay, guys. Anyways, for those who did not draw it, you will have to attempt the questions right now already today. And most likely for those who did not draw it, you do not know what's going on. But it's okay. Let me just give you a quick refresher of what you're supposed to know. Okay, guys, like I mentioned, this chapter here, we're basically learning how light rays behave in lens, right? And then I told you there are two main ways they'll ask you in the exam, right? In terms of lens, is let's say, for example, I have a equilibrium here, right? An equilibrium here, and then I say that this is my lens. Then obviously this will be the normal of the lens, which separates it exactly into half. This here will be the optical center. You're supposed to draw 3 cm away, and then this would be your first focal point, and this another 3 cm away would have been your double the focal point. Sorry, double the focal length, right? So you should have done this here. In your exam, usually yeah, you guys will see it later on. But anyways, today is going to be exercise day. In your exam, you're supposed to see that usually if let's say I have an object placed here, you are expected to draw 2 light rays, guys. You're expected to draw 2 light rays. And I mentioned the first light ray should be parallel with your equilibrium position here, right? So you must make sure it is parallel. But I can't check your answers right now because most of you guys didn't do it so correctly. Actually, Kunling one looks quite correct. I don't know if you followed the parameters then. Yeah, most likely not. Looking at it right now. Yeah. So you're supposed to have the first light ray that hits the normal, and then straight away this light ray here is going to cut through the focal point immediately already, guys. Then with this here, you're supposed to draw. This is your first light ray. Your second light ray will be starting from the object yet again and cut through the optical center directly here, right? Wherever the 2 lines meet, that is essentially where the image will be formed. From here, this image, you have to name the 3 characteristics of this image, which will either be real, virtual, magnified, diminished, or upright or inverted. Looking at this one here, it seems like it is real because it is formed by all these real light, right? These are real light, guys. And then obviously it is going to be, I mean, it looks enlarged, right? But you have to actually draw it for yourself, right? It is enlarged, right? Then after that, it is definitely going to be inverted, guys. What were the parameters? It's either going to be real, virtual, enlarged, diminished, or it's inverted or upright, right? These are the three main things that we talked about, And if you written down your notes here, you'll see that these are the characteristics, right? You're supposed to mention this one here. So in your exam, if they ask you to draw this one here, very straightforward, just go straight, cut through the focal point, cut through the optical center. That would have been your answer. But in reality, usually your exams they like to ask you the magnifying glass one. I've said this last week, I'll say this again. The magnifying glass is very, very, very important. If you you don't want to study anything, right? At least you memorize the magnifying glass one, because out of 10 of the past year papers that ask about lens, at least 5 or 6 of them is going to be asking about magnifying glass. But you're going to see the exercises later on. So let's say, for example, if this is a magnifying glass, the same thing, you draw your lens, right? You draw your normal. This is your optical center. This is your focal point. Maybe I want to make it larger, the focal point. A bit further, I mean. Focal point and focal point here. Now, like I mentioned, guys, who here can tell me where should I place my object if I want the lens to behave like a magnifying glass? Anyone can tell me where should I place my object? Should my object be placed here, 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 or here? 1, 2, 3, or 4. Let's put it for a vote, shall we? Everyone, can you send me a PM and tell me where should I place my object if I want the lens to behave like a magnifying glass? Some of you say 4. Some of you guys say 2. What about the rest? Everyone put down your vote, then I know who here has been not paying attention. Okay, Jun Hao here says 2. Come on, the rest of you guys. Scott here says 4. Hannah says 2. Where else? Shermaine says 2. Who else? Jen Lim, Lucas. And who else? If we're wrong, you're racist. Shut up, Kuding. Hey guys, the answer is actually supposed to be 4, bro. Bro, it's supposed to be 4. Why? What did I mention last week? I said that in order for the in order for the lens to behave like a magnifying glass, it must be placed in between the focal point and the optical center. In fact, it is given here as well. Look, this is your magnifying glass. Your object should be placed in between the focal point and the optical center, right? Only when you place the object here can you find this lens behaving like a magnifying glass. So from here, if it is behaving like a magnifying glass, oh, probably this is too tall, like probably this here. If you are asked to draw the light rays, same thing again, all right? First light ray will go straight, cut through the normal here, right? Then after that, cut through the focal point here. It looks something like this. Then your second light ray will cut directly straight through your, it will cut through your optical center straight away. And you realize at this point that these two rays are actually diverging away. And if it is diverging away, it means to say the image will not be here, right? Instead, what you're expected to do is you're supposed to draw one straight line. I mean, straight line in dotted format, right? Use your ruler. Then here also another straight line. Wherever the two light rays meet, guys, this is where the image will be formed. And from here, this image is real or virtual again. Let's see. Jen Lim, is this image going to be real or virtual? He's not here, is he? Oh, is it going to be real or virtual? Magnifying. Yes, it is a magnifying glass. Will it be real or virtual? This image here produced, will it be real or virtual? Real your head, real. It's virtual. Why is it virtual? Oh, it will only be real if it is formed by real light. You see these solid lines here? These are real light, right? But if it is formed by all these dotted line here, these are essentially virtual light. And if they are virtual light, then this must be a virtual image, right? That's why the first characteristics is definitely virtual. Will it be enlarged or diminished? Obviously, this is a rhetorical question, right? It wouldn't be much of a magnifying glass if it was diminished, right? So obviously it's going to be enlarged, right? And here, is it upright or inverted? Jun Hao, is this upright or inverted? Upright, excellent, because here it was pointing up. Now here it is pointing up, so it's definitely going to be upright. This is essentially all the things you should know for the lens, guys. Of course, sometimes in your exam, right, they may give a very special variation, which caught almost all my students off guard. You notice here, if you notice what I've mentioned since the last class, guys, by definition, right, the focal point, you see here, is a point where all the light rays converge, right? By definition, focal point is where all the light rays converge. By right, the light rays should converge here, converge here, converge here, converge here, and then converge here. This is supposed to be where all the light rays are supposed to meet, right? But when we draw the light rays from the lens, you'll notice that this one only got one light cutting, then you cut here already. Only one light cutting the focal point, 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 and obviously this one here also is only one light cutting the focal point. Now this here is happening because the object is not on the axis itself. You'll see that this object is actually away from this axis here, right? If the object is away from the axis, usually this is how the light rays are going to behave. But if, let's say, for example, I have an object that is exactly on the axis, let's say my object right now, right, is exactly on this axis here. How the light rays will behave will be very, very different now. If they ever ask you to draw, right, what's going to happen is you'll have to draw this, cut through here, draw this, cut through here, draw this. Usually they don't ask you to draw more than two, but I'm just showing you, right? All the light rays are actually supposed to converge at the focal point, meaning to say, right, the screen, you know, like how in the movies the projector is basically projecting images onto the screen, right? Your screen must be placed somewhere here. Then this is the point where all light rays converge. Then you will have a very sharp image. You'll have a sharp image here. What happens if, let's say, you move the screen forward? If you move the screen forward, let's say, for example, your screen is here, right? You see here got some light, 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 here got some light. If, let's say, your screen is positioned this way, what's going to happen is you'll actually have a very blurred out image, guys. You'll have a very, very blurred out image because the light rays are not all converging at one specific spot. So usually in cinemas, this is how the screen is going to be placed. It will be placed exactly on the focal point where all light rays converge. Then you're going to have like a very full nice screen. Okay, and these are the things you should know. If today the object is not on the axis, then you have to draw these light rays. Not on the axis, you have to draw the light ray. But if the object is on this axis here, you're expected to draw the light rays that will all converge in the focal point here. Anyone don't know what I'm talking about? This is very important now. Good. I can only assume 100% absorption rate, right? So having said that, yeah, for those who are uncertain, please do draw these images here. It is of grave importance. And finally, this is the last part here before I throw you guys into tons and tons and tons of exercises. Actually, not a lot, probably just a few pages. Just a few pages. It's a lie we tell all the time. But anyways, moving on to the final part here. This is basically dispersion of light, guys. Dispersion of light is essentially why rainbows are formed. Okay, why will light disperse into 7 colors is because, for those who do not know, white light, which is usually light from the sun, right, they actually contain 7 different colors. And the only reason why we see them in only one white color is because all these 7 colors are already like mixed together into one specific color. For those who have ever played a little bit of arts and craft in kindergarten, right, you'll have done something that's combined spin wheel. I think. Let me show you. Anyone ever played with this before? Right. Usually our kindergartens, no, really. Kindergarten school teachers, they like to, what the fuck is this? Never seen it before. So this thing here, right, is basically what happens when you combine all 7 colors together. If today the speed of the light is slow, right, you'll actually be able to see that there are 7 different colors here. But when, no, I didn't say it was something. But when you spin all 7 colors together, guys, when you spin all 7 colors in a very fast speed, right, what's going to happen is they will all combine into one color, which is usually the white color. So you see this guy, see what he's doing now. Look at this. Look at this. When he spins all 7 colors together, you'll see that at one specific time, it will be like white in color. Yeah, see this? I mean, if you what? Oh. Oh, okay. Yes, Jerry. Nice. But anyways, yeah, if you see all the 7 colors spinning at a relatively fast speed, right, you'll actually see that it goes into one specific color. This is essentially how white light is formed, guys. Okay, see, like if you see the speed slows down, right, as soon as the speed starts slowing down, you can see that the 7 colors are separating into different lights again. But as soon as the thing speeds up again, you see it goes back into white color. Right, do you see this here? So this experiment actually shows us that 7 colors, when they are going at a very fast speed, they actually turn into white light. And essentially, if we want the white light to separate into 7 colors, this is essentially how the rainbow is formed, right? So back into here. I swear, right? Zoom has been laggy as hell, man, recently. Every time when I try to share a window from Chrome and then I go back to my iPad, it makes me install this stupid plugin thing and then it always doesn't load. Okay, so basically dispersion of light is the separation of white light into 7 different colors. Usually dispersion is very commonly seen when the rainbows are formed after the rainfall. Right, what's actually happening is, right, the water droplets in the air will act as a prism, this prism here, right, which will have white light, which is usually the sun shining through. As soon as the white light shines through this prism here, right, refraction actually occurs. Okay, why? Because at this instance here, speed of light is 3 times 10 to the power of 8, right, meters per second. And when it goes into this prism here, right, actually the speed of light decreases. But because there are 7 different colors, the speed of light will decrease at different pace. You can see that red color is the closest one to the original path, right? This is because red in general has a much longer wavelength and thus has the greatest velocity here. This is yet again in line with the V equals to F lambda. Whereas you'll see, oh, sorry.
So why is it that red has a longer wavelength?
Wow. Can I say Jesus made it so? I don't know. It is that. It is what it is that.
Mid teacher.
I don't know why it has the longest wavelength, but God created it that way. Right. I don't know why, but red color in general has the longest wavelength. And because it has the longest wavelength, usually it travels the fastest here. Whereas violet, guys, violet actually has the shortest wavelength among all these 7 colors, right? And because it has the shortest wavelength here, what's going to happen is the speed is actually the slowest here. That's why you can see violet deviates the most from the original path. This was supposed to be the original path. Red deviates a little bit because the speed of red is faster than violet here. Okay, and obviously this here is what we call refraction, right? This is basically refraction of light, guys. The refraction of light will cause 7 different colors to separate into 7 different angles because of the 7 different speeds. And when it refracts one more time in this layer here, you'll see that the refraction is going to be opening up even more. And then, obviously with enough light and enough refraction, the rainbow is basically going to form in the sky, right? So this is essentially what we call dispersion of light, guys. If you look at the statement here, when light goes through a prism, it will refract. This effect is known as dispersion. It happens because white light is a mixture of all the colors in the rainbow. For those who have still a difficulty remembering the colors of the rainbow, you can imagine the rainbow color is like some guy's name, and this guy is called Roy.G.Biff. Okay, say it in your head a few more times, and you'll essentially remember all the colors are right. Roy.G.Biff is red, orange, yellow, green, blue, indigo, and violet here. Okay. Now, it is no coincidence that all the emergency lights are red in color, like ambulance lah, traffic light lah, all the so-called emergency colors are red in color because we want the light to travel fastest to our eyes. Imagine today lah, let's just say, for example, someone is dumb, right? And then they go modify their brake lights from red into this violet here. You know what's going to happen? The speed of light will be actually a little bit slower. And because human has reaction time, right? Our reaction time will actually take longer, and the tendency to have accidents is actually much higher. So, I mean, the difference is not a lot, lah. It's not like it's 2 or 3 seconds delay, that kind of thing. Probably the difference is like I don't know, maybe like 0.01 second here, and then this is like 0.04 seconds here. It's just a very small difference only, but at very crucial times, every small second matters, right? And that could, in a very crucial time, a very small second could lead to life or death, like, essentially. So, you know, like sometimes you see all the cars right on the road, you see like they modify their car, then the brake light is orange color lah, or violet color lah. Usually the Malays like to do this lah. I don't know why, right? But not racist ah. I see, I know already for sure. This guy is typing already. Weird ass name. Oh, my bad. But anyways, yeah. So, basically, you know, this is essentially what's happening. Shut up, this is essentially what's happening here, okay? So if you look at the statement here, white light is made of different colors with different wavelength ranging from 0.004 mm to 0.007 mm. It is essentially double the wavelength, which means to say it is actually almost double the speed, right? Because assuming frequency is the same. But from here, the final thing you're supposed to know is monochromatic light, guys. For those who have ever played with the lasers, you know, it probably like shine all the way to your neighbors before, right? Lasers usually will have one color only, meaning to say, right, if I were to shoot a red color laser here, it will not refract into 7 colors. It will just refract, and then it will refract here. There will still be one color. Monochromatic light, by definition, are light with only one wavelength or one frequency only. And this is always asked in your exam, guys. You actually need to know what a monochromatic light is. Mono is solo, chromatic is actually light, right? So monochromatic light means to say one single light, which usually will have only one wavelength and one frequency, meaning to say it will only have one color here. Okay? Yeah, and that's supposed to be it for this chapter here. Anyone's got any questions for this part here that they are uncertain of? Anyone wants to ask anything and clarify anything? How commit facts? What? Oh, what? Shut up, Lucas. Yeah. So, yeah, this is essentially everything else. How to break bad? What? What are you on about, Lucas? Okay, anyways, yeah. If there's no questions, guys, these are the exercises I would like you all to do right now, starting from the first question. Today is going to be exercise day, guys. I want you guys to finish as much as you can so that you'll have as little homework that you will forget to do as you can, right? Hey, by the way, did Tavish join again? Is he here already? Oh, he's actually missing. But thank God I recorded the whole thing. Okay. Hey, everyone, start doing this question here. I'm going to give you guys exactly 7 minutes to complete this, and I'm going to show you how to do it. Everyone, start attempting this right now. 7 minutes, guys. 5.36. Everyone, start doing this now. Okay, everyone. I hope you have all attempted the question here. Let's go through it together, guys, real quick. If you look at this question here, what do they want from you? Figure 7.1 shows an object and its image formed by a converging lens. One ray from the tip of the object to the tip of the image is shown. Now, after that, first things first is they ask you to pick a tick in all boxes that are correctly describing the image here. So first and foremost, I noticed that the image is actually pointing down. Originally, the object is pointing up. So I know for a fact that it's going to be inverted, right? This is for sure number one. I look at the size of the image and I compare it with the size of the object. The image is smaller than the object, so it's definitely diminished, right? And finally, since it is formed by real light here, I know it is going to be virtual, right? So from here, I would basically write inverted, diminished, and also virtual here. Okay, it's going to be inverted, diminished, and also virtual here. Then the next part here, they ask you on figure 7.1, draw a ray passing through a principal focus of the lens from the tip of the object to the tip of the image. Label the principal focus here. So basically, they're asking you to draw the first light ray, right? So if you're asked to draw the first light ray, oh shit, what did I say? It was, yeah, it is real. It was a test. Kunling and Jway pass. Aha. Yeah, I tell you, I've been having these problems, right? I'm thinking of one thing and I'm saying another thing recently. I don't know if it's old age or just getting dumb, but it is definitely real, guys. It's supposed to be. What does mid for real mean? Schizophrenic. Yeah, it's probably a combination of all the above and maybe some form of retardation also. But anyways, yeah, it's definitely supposed to be real. Yeah, because it's formed by real light, so it must be real, right? Then from here, they ask you to draw the light ray, right? And if they ask you to draw a light ray, looking here, this is the second light ray, right? Usually, if you're asked to draw the first light ray, you just draw the one that is parallel with the axis. Then this here, you cut through the focal point, but you don't know where the focal point is, but you can connect it to your image here. From here, I can tell that. No, I'm not 60 years old, Lucas, you fool. Right, I can tell that this is definitely going to be the focal point here, right? Then from here, they ask you the next thing, well, how much is the focal length? Your focal length, guys, is always going to be from where to where again? Let me ask. Jway, where is the focal length again? From where to where again? Lens to the point, not lens to the point. More specifically, is supposed to be the optical center to the focal point. This is what we call the focal length. So basically, it's not the same for sure. This is the lens, right? Is this here to here? No, right. Anyways, it's supposed to be focal point to optical center, right? So this one here, you measure yourself. I think if I remember correctly, it's like somewhere around 2.3 cm or 2.5, I don't know, right? Measure yourself. Okay. Then finally, the last part here, they ask you to draw another ray, not passing through a principal focus of the lens that passes through the tip of the image here, right? So usually, guys, in a normal scenario, we can actually draw up to 3 light rays, okay? You know how we originally say that it's going to be like parallel and then cut through the focal point, right? There is the third light ray that is going to be parallel, but starts from the image here, right? It's going to start from the image here. Then after that, it will cut through this focal point here as well, right? This here would have been a focal point. This here would have been the exact same focal length. But this question here specifically says that it cannot pass through the focal point. Sorry, it's not passing through the principal focus here, which means to say you cannot draw this third light ray, guys. You are actually instead supposed to understand that the image is where all the light rays are going to converge. So you're actually supposed to draw this here instead. You just draw one straight line that hits directly on the normal here, like somewhere in the middle or whatever, then you from there you continue drawing here. You draw until the image here, right? So it bends a little bit, guys. It kind of bends a little bit, but this is essentially what you're supposed to draw. Okay, everyone? Anyone's got any questions for this part here? No? Excellent. How many of you guys got everything correct out for this one here? You don't get the last one? This one? The donkey, is it? Yeah, the rest is correct. Oh. But wait, when you say you don't get, it means to say you don't get my explanation or you didn't get the answer? Oh, you didn't. Okay. Okay, let me repeat this part again. Right. So by right, in the normal scenario, you have drawn this, correct? Right. Then after that, they ask you to draw a third light ray that does not pass through the principal focus. In a normal scenario, you're actually supposed to draw this. You're supposed to draw horizontal, then cut through here, right? This is actually your third light ray, right? But in this question, they say cannot pass through this focal point. Cannot. So what you're actually supposed to do is you're supposed to draw the light ray inside of the lens, in between the first and the second light ray, which is supposed to go here, straight line until you hit the normal. And then after that, you're supposed to change your angle a little bit and straight line until you hit the image. This is going to be your third light ray for this specific question. You got me? Yeah. Okay. Good. All right, guys. Let's go for the next question here. Same thing, 7 minutes. Everyone start drawing this right now. And for those who are done drawing this, you can actually snap me a photo and check with me and see if you got it correct or not, guys. Yet again, 7 minutes, guys. Let's go. Jerry, your answer for the last diagram is correct already, but you did not complete the last question now. Draw one other ray from the upper tip of O to the image. So in this scenario, you can draw the one that I said you cannot draw. The third one, which is at the bottom there. You try to draw it and send it to me again. Yeah, this is correct already, Jerry. Excellent. Do the next one. Sorry, what do you say? Oh God, was someone talking to me? Hannah, are you sure you're on the right page? Oh, wait a minute. This is an exercise booklet. You should be on your notes instead, Hannah. How do you wait a minute? Why are you on this book? Wait, what? Oh, bro. This is from the notes, bro. What? Hannah. But yeah, your diagram looks correct lah, I would say. Yeah. But the diagram looks correct lah for this one here. Yes, at least you're not wrong, but it is the wrong booklet. Yeah, very good, Charmaine. Yours is correct already. Excellent. Okay, guys, I think all of you guys had enough time to attempt this question. Quite a straightforward one. First and foremost, they ask you to describe the full description of the image here. This is obviously a magnifying glass, right? Because it's the only way you can see that it's a magnifying glass, right? So magnifying glass would definitely be virtual, upright, and magnified, right? Or enlarged, or whatever way you want to put it. But it's supposed to be virtual, upright, and magnified, whichever way you put it, it doesn't really matter, right? Then using the letters of on 7.1, identify the focal length here. Let's see, who have I not asked? Lucas, what was your answer for this one here? Which one is your focal length? PQ, QR, or RS? Lucas, are you there?
Oh wait, sorry.
Which one? Which one is your focal length? PQ, QR, or RS?
RS.
Good, excellent. It is supposed to be RS. Well done. Okay, then this one here, very straightforward. Oh, sorry, they said wait. Oh, now I noticed a lot of you guys didn't give me this answer. You're supposed to draw your eye. You're supposed to, on figure 1, draw an eye and place it where it is suitable for you to view, guys. Your eye should be somewhere around here, guys. This is your eye, right? Yeah, it's supposed to be here. I think Jie, oh, you did. It was a small, little, beautiful eye with eyelashes some more. Nice. Charmaine, yours is not here. Right, yours was not here. But yeah, I'm supposed to draw the eye. Don't miss out this question here. Then after that, in this one here, very straightforward. You're supposed to draw a light ray, cut through the focal point. Oh God. Cut through the focal point and cut through the optical center. Oh God. Cut through the optical center. And wherever the light rays meet, this is essentially where your image will be, right? Then this one here, they say you're supposed to draw one more light ray. This time you can draw anything. Even if you drew the one in the middle here, guys, it's actually acceptable. But I would recommend drawing the exact opposite one. Then you draw, and I draw this one like this here. Okay. These are your 3 light rays that you're supposed to have, right? And then obviously you'll notice that by right, if you drew it correctly, these 2 are exactly the same length. They're exactly the same length because the focal point of light will enter 2 sides of the ray, right? So obviously there's going to be 2 focal points here. Okay. Oh, sorry. Before I move on, anyone have any questions for this part here? I assume it's a fairly easy question. Most of you guys should have gotten it correct. Can you do this last question here before we end the day, guys? Do this question in 5 minutes. And we'll discuss the answers immediately. Yeah. 5.58 here. Yet again, for those who are uncertain and want me to check your drawing, you can always snap a picture and send it to me. Okay, guys. Final question before we end the day. Yeah. All right, if you look at this question here, a glass converging lens is used as a magnifying glass. Oh, always comes up in your exam. Magnifying glass. Figure 6.1 shows the lens of the principal axis and two principal focus f1 and f2. On figure 6.1, mark a point on the principal axis, label it A to indicate a suitable position for the end. Like I mentioned just now, where should it be placed, Scott? Where should I place my end in order for this lens to behave like a magnifying glass? Between f1 and the lens. Excellent, good job. Right, I have to place my object in between here. That's the only way for it to behave like a lens. So, you're supposed to label it A lah. It doesn't really matter. Right. Now after that, on figure 6.1, mark a point on principal axis where the E is a suitable position for the I. The E is obviously supposed to be here. Right, because if you think about how the light ray is going to work, is like this object here, the light ray is going to be here, and then the dot, and this is where your image will be, right? Your eye must be somewhere around here, guys. All right. Yeah. Then after that, from here, the next part is take one box to indicate where on the principal axis the image of the end is. The image is definitely going to be here. So it should be towards the left of F1. Okay, it should be towards the left of F1. And finally, they ask you to use two words to describe the image produced. It is definitely going to be virtual, for sure, right? And it's definitely going to be upright, for sure. And in fact, if there was a magnified here, you can circle that as well. Okay. Then finally, a red light from the end passes into the lens. As the light enters the lens, state what happens to the wavelength. Definitely. Definitely the wavelength is going to decrease, guys, because light, when it enters a different medium, be it glass, water, or plastic, right, the speed of light is going to decrease. And when the speed of light decreases, according to your V equals to F lambda, this decrease, this is the same, this will decrease, right? Which leads us to the next question. They ask you what happens to the frequency. Frequency will always stay the same, regardless of whatever phenomena. Doesn't matter if it's a water going through reflection, refraction, or diffraction, or light going through reflection or refraction, the frequency will always be the same. Very standard question, very standard answer. You must know how to write this. And state how the wavelength of violet light in air differs from red light. Obviously, like I mentioned just now, red is the fastest one among all the colors, right? And because of that, the wavelength of violet is much shorter, whereas the wavelength of red is definitely much higher. Write down in words, then you'll get your marks already. Okay, everyone? Anyone's got any questions from this part here? Good, 100% absorption rate. Just what I like. Guys, please finish up the last three questions. This one, and also this one here. Kunling, there is homework. Kunling, there is homework. Kunling, there is homework. Kunling, there is homework. There is homework. Okay, please finish this up. We'll discuss the answers next week, and then we'll move on to the next chapter already. Because Kunling every day tell me there's no homework, then I have to search for some videos. Then I see what the hell I did is it make me doubt myself all the time. So now I got to repeat it 3 times. Yeah, targeted. Yep, for sure. All right, there is homework, guys. Please go attempt the homework, and then yeah, we'll discuss the answers next week. Oh, by the way, Lucas, can you stay back for a while? I want to talk to you before.
Okay.
Oh, yeah. But everyone else, that will be it for today. I'll see you all next week. Ta-ta for now. Hey,
Yeah,
Lucas,
sir. Yeah.
you remember the link that I sent you that is supposed to help you for topical questions?
Yeah, I can't find it, sir.
Nani, no worries. Let me send it to you again.
Wait, let's see first.
No.
Oh yeah, I think I found it. The Google Doc, right? Wait, no, that's not Google Doc. That's one. Okay,
It's okay. I'll send it to you again here.
Wait, is it the motion? Oh, I know there isn't.
Okay, let me share my screen. You're supposed to see this.
Okay.
You know, if you click this link here, which I will send it to you right now. Right.
Oh, so yeah, so I already have access to that. Why?
You have access to it? No worries. These are all your topical questions.
Yeah, I know.
I want you to finish everything.
Oh,
Oh, oh. But since you're still following the class right now, I think like general physics, you can do it after we have the class. Like on Monday, we did mass and weight density.
all right.
And the week before, we did motion already, right?
Okay.
I want you to do all this. I can check
Yeah.
who did and who did not do. So because you're in year 11 already, and then I
Yeah.
don't want you to struggle so much later on, right? Especially if you're taking 2 classes, you need to do it as time progresses. So like right now, we're done with this lens here. On top of the homework that we have, you need to do this one as well.
Okay, sir. Sure.
Okay. All right.
Yeah.
All right. I'll
All right,
see
thanks,
you
sir.
next week.
Okay, bye, sir.
Bye-bye.